evaluate the expression. We can change 1 whole into a fraction. So for example, 1 can be rewritten as 6/6. So if we subtract 1/6 from that, that leaves us with 5/6. You can change it into 3/3 or 4/4 or 2/2 to help with the subtraction in the remaining problems. Consider this spinner with 6 regions. What's the theoretical probability that it lands on A, B, C, D, E, or F? Well, all of those 6 make up the entire spinner, so that would be 1 whole or 100%. If we just look at the probability of it landing on F, F takes up slightly more than 1/4 of the thing, so our probability should be more than 1/4 as well. What is the theoretical probability that it does not land on F? Well, that is all of the ones besides F. That's slightly less than 3/4 of the full spinner. We would need some more information to figure out the exact theoretical probabilities. We would need to know what fraction of the spinner is taken up by each letter, since they're not the same size. Today we're going to look at some ways to find probabilities when outcomes in a sample space are not equally likely to occur. Here I have problem 1. It says, consider the chance experiment of spinning the following spinner. Each region of the spinner is the same size. Complete the following table for the theoretical probability of landing on each letter. Well, each of the pieces is the same size, and there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But there is only one A, so that is 1/10. There is one B out of 10, one C out of 10, 2 Ds, 2 E's, and 3 F's. What is the sum of all of the theoretical probabilities of your table? And why does it make sense? If I add all those up, I get 10/10, which is the same as 1. And it makes sense because all of the outcomes together would make up 100%. What does the sum of all the probabilities tell us about the spinner? Well, the probability of 1 means that it's certain. Or guaranteed to land on A, B, C, D, E, or F. What is the theoretical probability of landing on a region with the letter D? There were 2 sections labeled D out of 10. What is the theoretical probability of landing on the letter E or F? Well, E was 2/10 and F was 3/10, so that would be 5/10. When you see that phrase or, we combine E and F together to find the probability of both, or one or the other. What is the theoretical probability of landing on a region with A, B, C, E, or F? Well, A was 1/10, B was 1/10, C was 1/10, E was 2/10, and F was 3/10. So that's 3, 4, 5, 6, 7, 8 tenths. What is the theoretical probability of not landing on a region with a letter D? Explain how you calculated this probability. Well, the entire probability is 1 whole, and not landing on D means we need to remove the probability of landing on D. That would be 10 tenths minus 2 tenths, which is 8 tenths. Consider the chance experiment of spinning the 4-color spinner. Complete the following table for the theoretical probability of landing on each color. It's broken into sections. And there are 12 pieces in these sections. We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So for red, that is 1 out of 12. For blue, that takes up 2 sections out of 12. For the green, that is 5 out of 12. And for the yellow, we have 1, 2, 3, 4 pieces out of 12. Part A says find the theoretical probability that the spinner lands on yellow, red, or green. So yellow is 4, red is 1, and green is 5. So 4 plus 1 makes 5, plus 5 makes 10 twelfths. B, find the theoretical probability that the spinner does not land on blue. So remember, we take the entire probability, which is 1, or 12 twelfths, and we remove the blue because we do not want to land on blue. And blue took up 2 twelfths, which gives us a probability of 10 twelfths for not landing on blue. How do the theoretical probabilities in B and C compare? Explain your reasoning. These probabilities are the same, because if we don't land on blue, we must land on yellow, red, or green. Find the theoretical probability that it does not land on green. Well, the whole probability is 12 twelfths, and the probability of landing on green is 5 twelfths. 12 minus 5 is 7, so that is 7 twelfths. Find the theoretical probability that it lands on either blue or green. We're going to combine the blue and green sections together. Blue is 2 twelfths, and green is 5 twelfths, for a probability of 7 twelfths. Find the theoretical probability that the spinner does not land on blue or green. So the whole is 12 twelfths, not landing on blue or green Well, blue or green was 7/12. So we're going to remove blue or green. 12 minus 7 leaves us with 5/12. Ethan is concerned about eating enough vegetables. For 1 year, he records the daily number of servings of vegetables he eats. The table shows the relative frequency of each number of servings of vegetables that Ethan eats in a day. What is the sum of the relative frequencies in the table? So we're adding up all of these decimals here. And they all have a sum of 1. What is the empirical probability that Ethan eats exactly 2 servings of vegetables in a day? Well, exactly 2 servings would be 0.21. What is the empirical probability that Ethan does not eat exactly 2 servings of vegetables? Well, the entire probability was 1. So not eating exactly 2, we're going to remove the 2 probability, which leaves us with 0.79. What is the empirical probability that Ethan eats more than 4 servings of vegetables? So more than 4 would be 5 and above. Which comes out to 0.18. What is the empirical probability that Ethan eats 4 or fewer servings? We need to add all of those together. Which comes out to 0.82. F. What is the empirical probability that Ethan eats at least 3 servings of vegetables in a day? At least 3 means 3 or more. Logan records the number of work phone calls he receives each afternoon over several months. The table shows the relative frequencies for the numbers of work phone calls he receives. What is the sum of the relative frequencies in the table? Well, I have 6, 9, and 3. The common denominator for those would be 18. So we're going to multiply by 3. For this one, we would need to multiply by 2. For this one, we'll multiply by 6. And for this one, we'll multiply by 2. 3 plus 3 is 6, plus 4 makes 10, 16, 18, 18ths, or 1 whole. What is the empirical probability that Logan receives 3 or 4 work phone calls today? So this we changed into 6/18ths, and this one we changed into 2/18ths. They are equivalent fractions. Just to make it easier to add them together. So we need 3 or 4. 6 plus 2 is 8/18ths. What is the empirical probability that he receives fewer than 2 work phone calls? So fewer than 2 is 1 or less. which is 6/18, or you can think of it as 2/6 if you left them as sixths, or 1/3 if you reduced that. What is the empirical probability that Logan receives 2 or fewer? So now we're including 2 and 0 and 1. 4 plus 3 is 7, plus 3 is 10. If you reduce that, that could be 5/9. What is the empirical probability that Logan does not receive exactly 3 work phone calls? Remember, the entire probability is 1 whole, or 18/18, and we do not want 3, so we're going to remove 6/18. 18 minus 6 is 12, which you could reduce to 6/9 or 2/3. For problems 5 and 6, consider the following situation. When Kayla goes to the farmer's market, she usually buys some apples. The table shows the relative frequencies of the numbers of apples that Kayla bought each time she went to the farmer's market last year. What is the sum of the relative frequencies in the table? Again, we're going to change these to all be 12ths. So we can multiply by 2 here, giving us 2/12. And this one we can multiply by 3, giving us 3/12. One plus 2 is 3, plus 5 is 8, plus 3 is 11, plus 1 more makes 12. 12/12, or 1 whole. Kayla is shopping at the farmer's market today. Find the empirical probability for each event. She buys exactly 3 apples at the farmer's market. That would be 3/12, or you can leave it as 1/4. Kayla does not buy exactly 3 apples at the farmer's market. The whole probability was 12/12. Not buying means we're going to remove it. 12 minus 3 is 9. So 9/12. Or if you were to reduce that, it would be 3/4. Kayla buys more than 1 apple at the farmer's market. So more than 1 would be 2 and above. 2 is 5/12. 3 is 3/12. And 4 or more is 1/12. 5 plus 3 is 8, plus 1 more makes 9. Again, you can reduce that to 3/4. Kayla buys at least 3, so that's 3 or more. 3/12 plus 1/12 makes 4/12, or you can reduce that to 1/3. That wraps up lesson 6 for outcomes that are not equally likely. Check back for lesson 7.